B. Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this lecture, we are going to learn about register organization of 8086 microprocessor. In the architecture of 8086 microprocessor, we have seen that there are 14 registers available, and all the 14 registers are 16-bit registers. These 14 16-bit registers are divided into general purpose registers and special purpose registers. Here in the bus interface unit, we have seen some registers like segment registers and pointer registers. And in the execution unit, we have seen some general purpose registers like AX, BX, CX and DX. Along with that, we have seen two pointer registers and index registers. Now, so 8086 has 14 16-bit registers. Some comes under general purpose registers. So when we call as the register as a general purpose register means if that register is capable of holding the data, variables and also the intermediate results temporarily. Such type of registers can be called as general purpose registers. So for example, if we say the register AX, that is accumulator, BX register, which is called base register, CX register, which is called counter register, DX register, which we call as a data register or extended accumulator. So all these registers are 16-bit registers. They can be called as general purpose registers. Why? Because by using these registers, we can have the data to be stored, or you can give any variables. The same registers can be used to store any intermediate results temporarily. Next classification is special purpose registers. So in the registers classification, like if you go for segment registers, pointer registers, index registers, all these registers, they comes under special purpose registers. That means they are used only in different cases. So here, segment registers, all the segment registers here are 4. Code segment, stack segment, data segment and extra segment. So these 4 segment registers are 16-bit registers. And coming to here, pointer registers, we have 3 pointer registers: instruction pointer, base pointer and stack pointer. These 3 pointer registers are also 16-bit registers. And next here, index registers. In the 8086 microprocessor, we have 2 index registers, source index and destination index registers. So these 2 registers are also of 16-bit registers only. So with the help of this special purpose registers, why they are called as special purpose registers means these registers can be used only for some addressing modes only. Now, here totally 14 registers, 16-bit registers can be classified into 4 groups. So what are that 4 groups means? General data registers. So 4 registers comes under general data registers. So what are that 4 registers means? One is AX, accumulator, BX, base register, CX, counter register and DX, extended accumulator or data registers. So these 4 registers are called general data registers. And next classification is segment registers. So in 8086, totally we have 4 segment registers. The 4 segment registers are CS, code segment, DS, data segment, SS, stack segment and ES, extra segment. These are the 4 16-bit segment registers. And next classification is pointer registers and index registers. So total number of pointer and index registers available is here 5 registers. So what are that 5 registers means? Coming to the pointer registers, we have instruction pointer, base pointer and stack pointer. These are the 3 pointer registers. So all these 3 pointer registers are 16-bit registers. And coming to the index registers here, 2 index registers are available totally, that is SI and DI. So SI represents source index and DI represents destination index. So even these 2 registers are also 16-bit registers. And next register is flag register. So we have one flag register. So here the importance of flag register is, after performing the arithmetic and logical operations by ALU, the result of the ALU will be represented with the help of this flag register. So this flag register is also 16-bit register, but among 16 bits, only 9 flags will be used. Only 9 flags will be used. So among these 9 flags, 6 flags comes under conditional flags, and the 3 flags comes under control flags. So totally 9, and the remaining flags are don't care. So here this 4 general purpose registers, 4 segment registers, 5 pointers and index registers and 1 flag register together forms the 14 registers in 8086 microprocessor. Here all the register sizes of 16-bit only. Next, here the architecture of 8086 microprocessor is divided into BIU and EU. So BU stands for bus interface unit and EU represents execution unit. Here in the bus interface unit, some of the registers are available like extra segment, code segment, stack segment and data segment and instruction pointer. So with the help of these registers, bus interface unit is going to calculate a 20-bit physical address. So here all these are the registers available in the bus interface unit. So this is extra segment, code segment, stack segment, data segment and instruction pointer. Now coming to the execution unit. So execution unit is meant for decoding and executing. So in order to perform that, this execution unit consists of the registers like AX, that is accumulator, BX, base register, CX, counter register, DX, extended accumulator, SP, stack pointer, BP, base pointer, SI, that is source index, and DI, destination index, and also flag register. So all these registers are 16-bit registers. So here we can see this is AX, BX, CX and DX. All these 4 are called general purpose registers. So they are of 16-bit. Here these 16-bit registers can be used as 2 8-bit registers. So here AX accumulator can be divided into 2 8-bit registers as AL and AH. So this AL represents the lower order 8 bits in the accumulator, that is it will be from 0 to 7, and here this AH represents the higher order 8 bits of accumulator. So this will be from 8 to 15. Similarly, BX base register, 16-bit register, it is divided into 2 8-bit registers as BL and BH. So here this base register can be used to store the offset address also. BL is used to store the lower order 8 bits, whereas BH is used to store the higher order 8 bits. Similarly, this CX and DX, counter register and data register. So this data register is also called as extended accumulator. So these are the 4 general purpose registers, general data registers we can call. And here we have the stack pointer and base pointer. So these 2 registers are 16-bit registers. And here source index register and destination index register. So these 2 registers are 16-bit registers. They will be used during string operations. And here you can have flag register. So this flag register is a 16-bit register. The status of ALU will be reflected on the flag register. Now, so here as we have studied, the 14 registers available in 8086 microprocessor has been divided into different categories like general data registers, segment registers, pointers registers and index registers. Now we will discuss about in detail each classification. So first comes here general data registers. So here in the general data registers, first one is AX. It is a 16-bit register. If you wanted to use as 2 8-bit registers, we can use it as AL and AH. So AL represents the lower order 8 bits and AH represents the higher order 8 bits. Here, AX is called accumulator. Next, it is a 16-bit register. It can be divided into 2 8-bit registers as AL and AH. If you are using AL and AH, it is capable of performing 8-bit operations. Now, so this is the most general purpose register having multiple functions. Multiple functions means you can use the accumulator in order to store the result or in order to store any input value or in order to store any intermediate result temporarily. So in all these ways we can use this AX register. So that is why we will say here the AX register functions in multiple manner. So it is generally used for performing the arithmetic and logical operations. Now, coming to the next general data registers. Next register is BX register. It is a 16-bit register. So BX register can also be called as base register. It is a 16-bit register. You can perform 16-bit arithmetic and logical operations. If we want to perform 8-bit operations, the register BX can be divided into 2 8-bit registers as BL and BH. Now, so generally, this BX register is capable of holding input, or it is also having another function like the BX register can store the offset address. So as we have discussed, generally the offset address will be coming from any of the pointer registers, index registers or base register. So that is why here BX register is a base register. It can hold the offset address value. And next general data register is CX register. So CX register is a 16-bit register. But here if you see, the another name of CX register is called counter register. So it is a 16-bit register. If you wanted to perform any operations on 8-bit instructions, it can be divided into 2 8-bit registers as CL and CH. So CL represents the lower order 8 bits and CH represents the higher order 8 bits. So when this CX instruction can be used, so CX register, we know that it is called a counter register. So generally, we have to give input the count value in CX register. So which represents how many times the loop should be repeated or how many times the shifting operation should be performed, how many times the register should be incremented. Okay, so the count value should be given with the help of this CX register. Now, next general data register is DX register. So here, DX register can be called as extended accumulator or data register. Now, this is also a 16-bit register. We can use this 16-bit register as two 8-bit registers by writing DX as DL and DH. So, where DL represents the lower order 8 bits and DH represents the higher order 8 bits. Here, this DX register will be used during arithmetic and logical operations. And why this DX is called extended accumulator means, suppose for example, if we take the multiplication operation. So if you are going to do any two 16-bit numbers multiplication, the result will not be 16-bit. The result will be greater than 16-bit. So in such cases, if the result is greater than 16-bit, the lower order 16-bit result will be stored in AX register, whereas the remaining higher order result will be stored in the DX register. So that is why if AX is called accumulator, DX is called extended accumulator. So not only for 16-bit multiplication operations, for 32-bit division operations and all also, this DX register can be used. That is why DX is called extended accumulator. So DX is a 16-bit register. Now, so that is what about the 4 general data registers. Next classification of registers is segment registers. So as we know here, segment registers size is of 16-bit. Number of segment registers available in 8086 microprocessor is 4 segment registers. CS, that is code segment, DS, data segment, SS, stack segment, and ES, extra segment. So these are the 4 segment registers available in the architecture of 8086 microprocessor. Now, first we have to know what is meant by a segment. As we know here, the physical memory size of 8086 microprocessor is 1 MB. Since the 8086 microprocessor supports segmented memory concept, that 1 MB memory is divided into 16 logical segments and each segment size is of 64 KB. So each segment contains 64 KB of memory. Now, so here in the segment registers classification, so totally 4 segment registers are available. So here what are the 4 segment registers? Code segment, CS, SS, stack segment, DS, data segment, and ES, extra segment. So these are the 4 segment registers available in the register organization of 8086 microprocessor. So all these 4 registers are 16-bit registers only. Now, so let us discuss about each segment register in detail. Here, the first segment register is code segment. Code segment. So the name itself says this is the segment where actually the code will be stored. That means the program will be stored. So in this segment, the code or program can be stored. So its size is of also 64 KB. Now, so it is a 16-bit register containing the address of 64 KB segment with processor instructions. Here, generally, if we are going to use this code segment in order to give the segment address, we have to use this pointer register, that is instruction pointer register only we have to consider in order to get the offset address. So, to find the physical address, if the segment address is from the code segment, we have to consider the offset address which is coming from the instruction pointer only. So, by using these two, we are going to calculate a 20-bit physical address. Now, so this code segment register cannot be changed directly. Generally, then how it will be changed means the code segment register will be changed automatically. That means the code segment will be updated automatically when the instructions like for jump, for call and for return instructions are executed. And here coming to the next segment registers, the next segment registers are data segment register and extra segment register. So the data segment register and extra segment register both are same. That means both the registers will be capable of storing the data only. That means the inputs, the variables, all these things will be stored in the data register or extra segment register. Now, so the data segment register points to the data segment of the memory where actually the data is resided. Similarly, the extra segment register is another type of data segment of a memory. That is why we can call data segment and extra segment both as same. Function is same. That means the content what this data segment register and extra segment register is going to store will be same. That is data only. Now, coming to the detailed discussion about this data segment register. Here, this data segment register is a 16-bit register containing the memory up to 64 KB. So, this data segment register will be having its own segment address. And here, the processor assumes all the data that is resided in the data segment. That means what is the data available in the data segment means whatever the inputs we are giving in the program, the variables what we are considering in the program. So all these things will be stored in the data segment register only. So the registers like AX, BX, CX, DX contents, and also here the index registers like SI and DI. So all this information will be stored in the data segment. So simply to say, the variables or the operands will be stored in this data segment and extra segment. And here, data segment can be changed directly by using the instructions like POP, that is pop instruction, and LDS instruction. So LDS represents load string. When these two instructions are executed, the data segment register will be updating automatically. Next. So coming to the next segment register available in 8086 microprocessor, it is stack segment. Okay. So this is stack segment. This is also the segment register where its memory size is 64 KB. So this stack segment register is capable of holding the data which is related to the stack temporarily. Now, so it is a 16-bit register containing the address from 64 KB segment with the program stack. Now, here, when this stack segment register is used, in order to calculate the physical address, what type of segment address and what type of offset address should be considered. Here, the segment address will be coming from the segment register like SS, whereas the offset address will be coming from two pointer registers. One is stack pointer, or the offset address will be coming from another pointer register called base pointer. That means if we are going to calculate the physical address, if the type of the segment address is stack segment, compulsory to calculate the offset address, it should be from the stack pointer or it may be from the base pointer. So considering these two, a 20-bit physical address will be calculated. And so here also, this stack segment register can be changed directly by using an instruction called pop instruction. So what the pop instruction is going to perform means, the pop instruction, if it is executed, it is going to retrieve the contents from the stack. So that is what about the information of the 4 segment registers available in 8086 microprocessor. Next, classification of registers is pointer registers. The pointer registers available in 8086 microprocessor is stack pointer, base pointer and instruction pointer. So all these pointer registers are 16-bit registers only. Now, so coming to the detailed discussion about each pointer register. So here comes the stack pointer. So stack pointer will be represented with SP. So what the stack pointer indicates means, the stack pointer indicates every time the location of the top of the stack, or we can say the address of the top of the stack. So stack pointer always points towards the top of the stack. It consists of the address of the top of the stack. So for example, in any case, if the stack is empty, it is going to store the location or the address of the stack as FFFE. Next pointer register is BP. So BP represents base pointer. Here, this base pointer generally it is used to access data on the stack, and also it is going to use in order to access the data from other segments also. So if the stack pointer points towards the top of the stack, the base pointer can point towards any location in the stack. And another pointer register is IP. So IP represents instruction pointer. So as we know here, the instruction pointer, it holds the address of the next instruction that is going to be executed. After each instruction is executed, the instruction pointer will be automatically incremented. So this is the information related to the pointer registers available in 8086 microprocessor. And next category of registers available in 8086 microprocessor is index registers. Here, if you see the architecture of 8086 microprocessor, so totally 2 index registers are available. So the 2 index registers are SI and DI. So SI represents a source index. Source means input. So using the SI register, it is possible to give the inputs, especially string. Set of inputs can be given by using SI register. And next index register is available DI, destination index. It is also a 16-bit register. So destination stands for output. If you wanted to see or if you wanted to locate any output data, we can use the register called DI register. So using this DI register also, you can do the string operations only. So DI is capable of holding the string data. Now, so in detailed discussion about index registers. So the first index register is SI register. So SI represents here source index register. So it is a 16-bit register. So generally the source index and all will be used during string operations. If we wanted to give 1 or 2 inputs, we can give by using a simple registers like general data registers, AX and BX registers. But if we wanted to give more number of inputs, we cannot use the registers like general data registers. We have to use the registers called SI and DI, that is index registers. Here, more number of inputs cannot be given by using a registers. Why? Because the registers available in 8086 microprocessor is less. That is why, in order to use efficiently the registers, in order to give string inputs or to perform any string operations, we have to go for using more number of inputs by using this SI and DI registers. So SI means source index. So using that, we can give the source. That means input string can be given. Now, if you are using this SI register, it is going to produce the offset address. Then, how the segment address should be calculated means, in order to calculate the segment address, we have to go for considering the data segment, because you are going to give data as an input. From this data segment address can be considered, and from this SI register, offset address can be considered. So using these two, we are going to calculate a 20-bit physical address. Now, so here SI is used for index, based index and register index addressing modes. That means here SI is a register which can be used only in these addressing modes. And next index register is DI. So DI represents destination index. Destination means output. So if we wanted to store any output data which is in the form of a string, we have to go for using DI register. So here DI register is also a 16-bit register. So since it is index register, DI is going to produce the offset address. So here this DI is a destination index register, and it is used to point destination in some string related operations, and its offset value is calculated from an extra segment register. Now, similarly here, if you are using DI register, where we have to use the DI register means especially in some addressing modes like index addressing mode, based index addressing mode, register indirect addressing mode. So only in these addressing modes we have to use the register DI. So that is what about the index registers available in 8086 microprocessor. Here all the 14 registers have been discussed, and we have seen what is the purpose of each register, by using which register what can be stored, and in which addressing mode which registers can be used. And in order to calculate the physical address, we need to have the segment address and offset address. Segment address will be getting from the segment registers, 4 segment registers, and offset address will be getting from any of the pointer registers or index registers, or also base register. But here, while considering the physical address, if this particular segment is used, what should be the offset address? All these constraints should be considered. So here are the functions given here. So here if you are considering the segment as code segment, from this code segment, we will be getting the segment address. And if the code segment is used, compulsory, you have to consider the offset address from IP only. IP represents instruction pointer. So from this pointer register, offset address will be getting. So from this segment address and instruction pointer, that is offset address, a 20-bit physical address will be calculated. What is the physical address? Physical address is the address where actually the operand is resided. So if this CS and IP is considered, the type of function that is performed is, it is going to show the address of the next instruction. And if the segment address we are getting is from the data segment, and the offset address should be considered from BX, DI and SI only. So BX means base register, DI means destination index and SI means source index. That means from any of these 3 registers only, the offset address should be considered if the segment is data segment. So from this DS, we will be getting from the segment address, and from these, any of these three registers, we will be getting the offset address. And if this is the case, the type of function that will be performed is, you can see the address of the data. And next is SS. So if the segment address is from the stack segment, compulsory the offset address should be from any of these two registers. So the two registers which will be giving the offset address is, one is SP, stack pointer, another one is BP, base pointer. So these are the two pointer registers we have to consider in order to give the offset address. Considering this stack segment and offset address, the function that is performed is, we can know the address of the stack. And the last one is extra segment. So data segment can also be called as extra segment. That is why, so whatever the registers we have considered in the data segment to calculate the offset address, the same registers will be there for extra segment also in order to find the offset address. So the offset address will be getting from any of these registers. It may be from base register, or maybe from destination index, or maybe from source index. And this is the extra segment register which will be producing the segment address. And using these two, segment and offset address, the type of address that can be performed is here, address of the destination data. So here, whatever the segments you are considering, we have to follow these pointers, index and base registers in order to know the function of the microprocessor. So this is what about the register organization of 8086 microprocessor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.